Okay guys, this is the first video of the second part of the structure of chemistry participation assignment. If you're watching this video, I assume you got here by going to your home page of the chemistry course and then clicking on assignments and then going to the structure of chemistry part 2 assignment and then clicking on the video of the or clicking on the participation assignment worksheet and opening that up, and then clicking the structure of chemistry Nearpod presentation, and that should lead you to this welcome screen, and you've signed in, you put a name in there, and then you've joined the lesson, and that should take you to the screen. So I've backed up a couple of slides from where we left off on the last presentation, just because it's a more logical place to start. One thing I need to tell you is that in order for me to put the words into the blanks here, it's going to be the easiest thing for me to actually open up the notes feature here, and this notes feature is available to you in Nearpod. You can write your own notes for the lectures, and then you can send them to yourself via email or save to Google Drive or save to OneDrive. I'm just going to send these to my email address here, jay.marshall@summitacademyschools.org. Okay, so I'm going to pretend that I'm taking notes here, but what I'm really going to do is I'm going to just type the answers to the blanks in here so you can see them rather than me just telling them to you and then you not hearing me. So that's how we're going to get the words into the blanks here. And where we left off last time, we had started talking about states of matter, and recognize that this part of the graphic organizer is the upper part of the graphic organizer, where we're going to say that matter has states of matter, okay, physical states, and you're aware that those main physical states are solid, 28, liquid, and 29, gas. Okay, now you're totally familiar with the idea that we have solids, liquids, and gases, and these are physical states, and that we can change between these physical states. We can change from a solid to a liquid to a gas. And you're also aware that the way that we do that is we heat the substance up. If it's a solid and I heat it up, it turns into a liquid. If it's a liquid, we heat it up and it turns into a gas. But what you may not be familiar with right here is the concept that the state of matter reflects the strengths of forces of attraction between particles and the amounts of energy that the particles have. So let's see how this works here real quickly, just to make it so that it makes sense for our graphic organizer. We want to make our graphic organizer make sense here. So I'm going to go to the next slide. And if you consider a group of water molecules, I've got a group of water molecules here. There's one water molecule, there's one water molecule, there's one water molecule, here's another water molecule, and they're H2O, right? And hopefully you remember Sperry telling you in biology that because the oxygen in the water molecule pulls shared electrons toward it more strongly than the hydrogen atom does, the oxygen ends up with more negative charge near it, while the hydrogen atom ends up with less negative charge near it. And I've indicated that here. I've got a little negative charge here by the oxygen atom, a little positive charge here by the hydrogen atom, and this makes the water molecule polar. The oxygen end is more negative, the hydrogen end is more positive. So what that means is that if I've got one water molecule here next to another water molecule, the negative part of this water molecule, where the oxygen is, can attract or create a force of attraction for another water molecule for the positive part of it next to it. And we call this force of attraction, hopefully you remember this term, we call that a hydrogen bond. Okay? So what? So we've got these forces of attraction. Well, what that means is that these water particles have forces of attraction for each other, and they should be able to hold each other together. They can lock each other in place or hold on to each other to change the state of matter depending on how much energy the water particles have. So if these are all little water particles, these little black circles in here are water particles, and I've got lots and lots of temperature, high energy, the particles are going to be moving so fast that it doesn't matter how strong the forces of attraction for each other are. No matter how much each water particle wants to grab onto each other and attract the other particles, they're not going to, because the particles are simply moving too fast. But if I slow the temperature down a little bit, I lower the temperature, the particles are going to be moving slower. So guess what? These forces of attraction between the water molecules can develop, and the molecules are going to hold together enough to form a liquid state. Okay, they're going to be cohesive enough, or they're going to be close enough together that they form this liquid state. They can still move past each other, but they're not locked into a rigid solid at this point. But then if I lower the temperature still further, I'm going to make it so that the forces of attraction are so strong they lock each other into a rigid pattern, and we recognize this as a solid. Okay, and this is true for any substance. When a substance is a solid, the particles are moving slowly enough that the forces of attraction are going to lock those particles into a solid state. If I increase the temperature, the particles are going to be moving faster, and they're not locked into a solid state, but they're not flying apart from each other like a gas either. They're in a liquid state. And then if I increase the temperature enough, I can make it so that the particles are moving in a gaseous state. The forces of attraction are not present for any of them. Okay, so this is, so for example, a substance that has a really low a point of forming a solid, a really low melting point, might be like hydrogen gas. The forces of attraction between particles of hydrogen gas are so small, or so weak, that I have to lower the temperature really a lot, to close to absolute zero, before I can get those things to turn into a solid. Okay, so that's the idea. And we're going to call this theory that the amount of energy and the motion of the particles is what is responsible for the changes in state from a solid to a liquid to a gas. We're going to call this the kinetic molecular theory. And your understanding of this is why I wanted this on the graphic organizer, so that's why we're going into this much detail at this point. Kinetic refers to motion, and molecular refers to particles. In other words, the particles in motion theory. Hopefully it makes sense that we would call our theory that if I increase the temperature, the particles are going to move faster and I'll change state. Hopefully it makes sense that we're going to call this theory the particles in motion theory, or the kinetic molecular theory. Okay? Now, the other thing that is related to this that we want on our graphic organizer, and by the way, recognize that I now have two number 33s, so on your worksheet, if you could add another 33 and write in kinetic molecular for that spot on your worksheet, I'd appreciate that. But now we have another thing that's related to this the gas laws, and we'll talk about these later in the course, and I'm only going to briefly describe what I'm talking about here. There are physical laws that describe the relationship between the temperature, the pressure, the volume, and the number of particles that are in a gas sample. There are some laws that describe the relationship, and I'm going to go to another screen here real quickly to show you what I mean by this. Okay, so I'm going to pause the video and go into another screen, and then I'll come back. Okay, so suppose I have a container. Let's make the size of that bigger. Suppose I have a container. You don't need to draw this. Suppose I have a container, and in the container I have 5 particles of gas, and they're flying around and they're smacking the walls of the container, and when they smack the walls of the container, they exert a pressure. Okay? They exert a pressure. Now, if I double the temperature, what's going to happen to how hard the particles smack the walls of the container? Hopefully it makes sense that if I double the temperature, the particles' motion is going to double, and they're going to smack the walls of the container with twice the force. So I'm going to increase the pressure by twice as well. Okay? Now, what happens if I add 5 more particles in here? What is that going to do to the pressure? So if I double the number of particles, I'm going to double the pressure by twice again. So if I double the particles and I double the temperature, I'm going to multiply the pressure by 4. And so the laws that explain this are the gas laws. Okay, and I just wanted to illustrate that for you. We don't need to know anything about them at this point in time, but I want to add this to our graphic organizer, so I wanted to tell you why we were doing that. So I'm going to pause the video again here real quickly and then go back to my main screen. Okay, so this should get us back to the correct point here now. And what I want you to do then is add to the graphic organizer. So again, if you have thrown the other one away, you'll need to make it up to the point we had it before. And then we're adding matter has physical states, and it has solids, liquids, and gases. So it has these 3 states. And we want to say that the thing that makes us go between these physical states is explained by the kinetic molecular theory and interparticle forces, the forces between particles. And then we're going to say that especially we're wanting to learn about the gas laws. Okay, so this gets us to this part of the graphic organizer. So go ahead and add that to the graphic organizer, and then I'm going to end this video and go to another one so that we can have more time. Each video can only be 15 minutes long, and we're at 13 minutes, almost 14 minutes right now. So we're going to stop this one, and then we'll go to the next one, and we'll pick up again at this point in the presentation. You can leave your Nearpod open, but then go to the other video. Okay?